You're gonna do? You got the April SAT coming up soon that you take during school, and I think all public school students take that for free. I don't know if you can opt out if you take it on your own. It's like I'm tutoring public school people, and they haven't told me about this, but they've told me about other SATs they're taking. Or maybe it's because they're a senior. I actually don't know what grade they're in. So I think juniors take this. I don't know if all grades take this, but there's a lot of juniors out there. So let's do this test. So here, what is the slope of the graph? Starting off real easy. It's very nice when they start off easy. Studies do show that if the first test question is easy, people do better on the rest of it. So slope, mx plus b. The slope is always the number multiplied by the x. Here, what value of x makes the equation true? I mean, we'll just solve for it. We'll just distribute and then add the 8, subtract the x. We get x equals 8. No problem. You see why I think this one might be easier than the other ones? And then here, the graph, I always say when you're trying to graph an equation, you start with the y-intercept. Looks like the y-intercepts are all 4, so that's not very useful. So then we go to the slope. I'd say the slope is positive, so we're looking for the line to be going up. So goodbye, goodbye. And then 3. So 3 is steep, right? That's how I would do this. I always think about 1. See how like a slope of 1 goes through the middle? So a slope more than 1 is going to be steeper than that. A slope less than 1 is going to be less steep than that. So that's how I think about slopes. And we just look at it quickly and we know. So here, what is the best interpretation of the slope? I always say the best interpretation of the slope is that it's a rate. So we're looking for the word rate or like a per hour type of thing. So I mean right here, an hourly rate, that's pretty good. One-time fee? No, that's the y-intercept if we're talking about the one-time fee. Total amount? Nah, it's not a total amount. We're always looking at a rate, and it's not the maximum amount. So yeah, the slope is always a rate. It's the rate of change. Rate of growth. Alright, so we're trying to solve for x. We just look at the equations, we can see that. So we just got to get x by itself. So peel everything away from it. Multiply both sides by 2y. So 2yz is x plus 3. So then you just got to subtract the 3 over. So 2yz minus 3. Beautiful stuff, beautiful stuff. Stop me if you got any questions. In the figure shown below, a parallelogram, you got that, you got the square, you got the area of the parallelogram, and you got the area of the square. Really? So that's 64, the whole thing is 112. And then they want to know what AE is. So the point they're trying to get here is, so we've got the whole area is 112. We got the inside square. Actually, no, here's what we should be thinking about here. Is we should be thinking about if the area of the square, we know that little section is 8. And then we also know that this is 8. And then how do you get the area of the parallelogram? You just do the area of the entire base times the height. So we got that area, which is actually just 112, is 8, the height, times the entire base. So if we divide by 8, I would just do halves. So 56 over 4. Maybe then you see that's 14, but we can just keep halving. 28 over 2 is 14. So then we know the entire base is 14. So if this entire length is 14 and this little bit is 8, we know this part has to be 6. And so you could have also done that with like area of triangles, but you should remember the area of a parallelogram. It's also on the front here, right? No, it's not. But recognize that the area of a parallelogram is really just the same as the area of a rectangle. Because you just I kind of drew that wrong. The idea is you can take this bite out here and you just move that triangle over here. And then you see how this parallelogram would have the same area as the original rectangle. Because we just took the triangle from the left side and moved it to the right side. So that's why the area of a parallelogram, base times height. Very good. Function n models the amount, yada yada. How many Earth masses were there when the star exploded? Oh, wait, what? The function n models the amount of nickel-56 and Earth masses remaining t days after a massive star explodes. So right when it explodes, how many days have passed? 0. It's an initial condition. I always say if you're looking for an initial condition, that's a y-intercept. Looks like it's about 24,000. Ooh, I don't like these questions. Which of the following piece of information is sufficient to prove the triangle ABC is isosceles? So which condition by itself? Well, yeah, I mean, ABC. So if this is equal to this, that by definition makes it isosceles. But also, if those two angles are congruent, that by definition makes it isosceles, right? Congruent angles mean you have the same side lengths. And the same side lengths means it's isosceles. So, yeah, both of those work. Both are sufficient. Either is sufficient. Yeah. Because if triangles have the same angles, they also have to have the same side lengths. Okay, which expression is equivalent to this? So this is difference of two squares. This is factoring. So you need to be able to recognize that this 16, like that's something squared. This 81, that's something squared. So this bottom down here, right away, you can do difference of two squares and say that it's 4 plus 9x squared times 4 minus 9x squared. And then you recognize again, this is also difference of two squareds. 4 minus 9x squared, both of those are squared things. So that, you can make that to be 2 plus 3x times 2 minus 3x. Right? And so now we're left with these things on the bottom, and see how that just cancels. So yeah, difference of two squares. Absolutely critical. So what were we left with? The minus 1. C. Very cool, very cool. So here, what are the solutions? We try to factor. You can't factor. So then you just got to use the quadratic formula, and you just got to know that. So what is the quadratic formula? Negative b plus or minus the square root of b squared minus 4ac over 2a. So then it's 7 plus or minus the square root of 49 plus, because c is negative 1, 12 over 2a, 6. So you see 49 plus 12, that's the 61, and it needs to be a positive 7. So B. Which equation represents this model? So it's negative. We'll start with that, so we know our squared thing has to be negative. So not like that one, and not like that one. And then you look at how it's over 30. So that has to be C, because this one has nothing going on with the x-coordinate. It's not moving it sideways at all. It needs to be moved sideways, so it has to be that one. How many solutions does this equation have? Well, we should really probably, I don't know, we just look at it. Well, so the whole point is what happens right away. Over here, when you distribute, you have x plus 2x minus 8. So what do you end up with? You end up with 3x minus 8. So we have 3x minus 8 equals 3x minus 8. So any value of x works, right? Because those are just the same thing. Infinitely many. What other people will say is, like, if you kept trying to go, everything just cancels out. You end up with 0 equals 0. And that's just always true. So if 0 equals 0, what x values make 0 equal to 0? All of them, because 0 is always equal to 0. All right. So here, just using exponent rules. This should be no problem. We just say, what do these exponents do? So this notation might be a little confusing, but you've got a parenthesis raised to an exponent, so you should know that means you multiply them. So we have k to the 5 over 16 times k to the multiply fractions, you multiply across, 15 over 16. And then now what? If you're multiplying two things that are raised to an exponent, base is the same, you add the exponents. So now we have k to the 20 over 16. We already have a common denominator, so that's great. And they want us to put it as a root still. So you might see that 16 and say, like, oh, well, it's got to be that. But no, because this fraction simplifies, right? You can actually cancel out an entire 4. So you end up with 5/4. So then what is that? I kind of think about it like the fraction almost like falls over. Oh no, actually the fraction doesn't fall over. It the root is on the bottom. That's what you remember. So this is the fourth root of k to the fifth. If we wanted to simplify it, we could pull some of these out because there are 4 k's in here, right? So we could rewrite, could pull one of that k out and say that that is still left there. I don't think that's actually what they want us to do, though. They just want us to leave it as this. Sweet. All right, a company offered its salespeople 2 different compensation plans. Sales plan X earns $1,000 and 10% commission. Sales plan Y earns $500 and 20% commission. Which inequality models the amount of D for which salesperson X earns more than Y? So we've just got to write these 2 equations and then say that the X equation has to be more than the Y equation. So what are these equations going to be? Well, so D is the dollars in sales they're doing, it looks like. So if we take the dollars in sales we do, for X at least, you're going to multiply that by 0.1. You're going to take 10% of that. And you're going to add on an extra $1,000. So that's how much person X is making, or plan X is making. And we want to know when that is more than plan Y. And plan Y is the same idea, except they're only starting with $500, but then they get 20% of how much they sell. So 0.2 times D. Now we just got to get D by itself. So the way I would do that is I would subtract, and I would subtract. So I'd have 500 is greater than 0.1 D. And then you got to multiply by 10, or divide by 0.1. So both those are the same thing. And then you get that $5,000 is less than D. So if you're making less than $5,000 in sales, you should go with plan X. And if you're making more, you should go with plan Y. And that makes sense, right? That if you're making more of sales, you'll be able to take advantage of that commission. So if you're making less than $5,000, you stick on plan X. More, you go to the next plan. All right, here. So you gotta be careful here, because like always, I would say you start with the y-intercept, and so that might make you jump straight to C. But remember that like what the y-intercept actually is. Normally, it's just this number right here, because you have something like this, where when you make x equal to 0, this just goes away. But that's not what we have here, right? So here, when we make x equal to 0, what is 2 to the 0? Of course, a lot of people are tempted to say that it is 0, but it's not. Anything to the 0 power is 1. So it is true, and I would say this is how we should find it, is that we should look at the y-intercept, but that doesn't mean that it's just C. It means that when we plug in 0, we need to get -1. So you see here, we would get 1 minus 2, which would be -1. So it needs to be D. Alternatively, you could say when you plug in 1, you have to get 0. And again, you could look at the answer choice D and say 2 to the 1 minus 2 is indeed 0. All right, we are flying through this section, which is great. What is f of 0? So f of 0, I mean, that's not multiplication. That means what is the function equal when x is equal to 0? That would be 3. What is the positive solution to this equation? So it's a quadratic, so we're going to try to factor. We're going to set it equal to 0 and try to factor. So we'd use the quadratic formula if we needed to, but I don't think we do need to, because we can factor it to be this. And that means it's 1 and -3. And they're asking for the positive solution. You can't grid a negative solution anyway. So the answer just has to be 1. Very nice, very nice, very nice. Okay. The graph of the line passes through that point and crosses the x-axis at that point. The line crosses the y-axis at that point. What's the value of b? So here's what I would do. They tell us 2 points that it's crossing. So if I know 2 points that it's crossing, then I would write the equation of the line. I would want to just do point slope form, personally. So I would say, what is the slope? We're going down 2 and up 4. So that's the slope, -1/2. And then what do? We do times x minus an x coordinate. I'll use 10 because that just makes that y minus 0. And so now to get the y-intercept, that's what they're asking for, right? Crosses the y-axis at what point? Well, we can just put it in slope-intercept form, which just involves distributing this negative 1/2. So we have negative 1/2 x plus 5. And that 5 should be the y-intercept. Yeah, easy enough. So here we got a system of equations. So people are all about the substitution. Substitution is not the move to solve systems of equations. People feel like people get caught up on it because it's the one that's introduced first normally, but no, you really should be using elimination. And here we're trying to find the value of y, so that means we should be trying to eliminate x since we don't care what it is. So you can see we do that by multiplying the top by 4 and the bottom by 3. So then what do we have? We have negative 12x plus 16y equals 16. And we have positive 12x minus 9y equals 1.5. And so now we can add them together. So we get 7y equals 17.5. And then we have to divide by 7. Well, that's kind of some tough math, but it's actually not. I guess you have to be a little smart about it here. But look at how if you multiply the top and bottom by 2, what's 17.5 times 2? 35. So we end up with 35 over 7 times 2. And look at how now you can cancel out these 7s. Because 35 divided by 7 is 5. So 17.5 divided by 2 is 5 halves. Which you could also see in other ways. Yeah, I mean that's definitely the best way to solve this problem. Elimination, especially when the coefficients are all mixy-matchy like that, elimination can be so bad. You'd have to deal with fractions so much more. You would, of course, get the same answer. All right, here we want the radius. They ask for this all the time. We did this on yesterday's test as well. You just got to complete the square. So what is the pattern? You do 6 divided by 2 to get you your 3, and then you subtract that 3 squared. Do the same with the y's, and now you might notice we're going to have a fraction, but we'll just have to deal with it, and that should be fine. And actually, it looks like it's going to combine pretty well with the other fraction. Because what do we have? We have plus half of 5, which is just 5 halves, minus that squared. So we just square the top and the bottom. Let's get this nonsense out of here. And then we still have the equals negative 45 over 4. And see what I mean, because now when we add 25 over 4 to both sides, there's already a common denominator. So we would just end up with negative 20 over 4, which is just negative 5. So that's great. And then we're going to add the 9 to the other side, and so we end up with 4. So our final equation is x plus 3 squared plus y plus 5 halves squared. No way to get rid of that. Equals 4. So what's the radius? Not 4. The square root of 4, which is 2. So people are always quick to remember that like the number over here is the radius squared. But very important to remember, you've got to complete the square first before you're going to do any of that. And that's that entire section. Let's check the answers real quick. Okay. Math, no calculator. D, wow, a lot of D's off the top. I don't remember that. D, oh, 2 D's. 3 is C, 4 is A, 5 is B, 6 is A. Very good. 7, we got DCC coming up. We got 10 as B. We got 11 as C. We got 12 as D. We got 13 as B. We got 14 as A. We got 15 as D. We got 16 as 3. And then 1. And then 5. And then 5 halves. Which I erased my answer, but remember how we got the 5 halves down there. And 2. Very good. Very good. Perfect score. Perfect score. You love to see it. All right, now the calculator section. We'll only use the calculator when we need to, of course. So which equation has the same solution as this? So they're really just asking which equation is the same equation. That's how it works in my mind. So they just want us to move some stuff around. They're just asking us to subtract 2x from both sides. So, like, that's a weird question, but don't get weirded out by it. They're just asking you to move some stuff around. All right, k of 1. Remember, that's not k times 1. That means when you replace x with 1, what do you get? 3 minus 5 over 2 plus 3. Boom. When the temperature of water is 25 degrees Celsius, sound travels through the water at 1500 per second. At the same temperature, about how far in meters will the sound travel in 15 seconds? Okay, they're just asking us to do 1500 times 15. It's 1500 meters. So this is like dimensional analysis, I guess. You go 1500 meters per second, and we're doing it for 15 seconds. So 1500 times 15. Don't need a calculator because 15 times 15 is 225. A digital artist resized a rectangular image. The ratio of the length to width of the image did not change. The width of the new image is 3 times as long as the original width. Width of the new image. Oh, she made it bigger. Okay. If L is the length of the original image, what is the expression represents the length of the new image? It's 3 times as long. Wait, the width of the new image is 3 times the width of the original image. Oh yeah, L is the length of the original image. It's just 3 times as long. Don't think too hard about that. They multiplied the width by 3, they multiplied the length by 3. That's how it works. They're not adding because that's not like proportional in terms of a ratio. If you multiply by the same thing, they stay in the same ratio. Okay, which of the following is closest to the percentage of participants who gave a 5 rating? Okay. How many employees were there? There were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so we'll be breaking out the calculator. And they're asking for how much did a 5? 2 of them. So the answer should be 2 out of 11, which I guess we don't really need a calculator. That's 18%, because that's going to be a little less than 2 to the 10th, which is 20%. Okay, what is the ratio of the number of participants who gave a rating of 6 or higher? How many did 6 or higher? 1, 2, 3, 4, 5, 6, 7, 8. Oh, they're in order. Okay. 6 or higher, 8. So the number of participants who gave the rating lower than 6. 3. 8 to 3. That's weird. There's no simplifying. So notice they're not asking to the whole thing. They're not asking for the ratio to the whole thing. They're just asking to the ratio of lower than 6, which was 3 of them. Okay. In Chicago, Frank Duryea won America's first automobile race by driving 52.4 miles in 10 hours. Wow, okay. If he drove at a constant rate, the approximate distance he drove during the race would be modeled by 5x. What graph best represents this relationship? Okay, so we're just looking for the graph of 5x. That was a roundabout way to ask that. So the y-intercept is 0. You always start with the y-intercept. That means you cross off all of those. And then you look at a specific point. You say here, when you plug in 2, you get 10, which is what we want. Yeah, there's no crazy unit weird stuff going on, right? No. We're just trying to graph that equation, plug in 2, you should get 10. All right. Here, there's unit stuff going on. A certain soccer field has an area of 7,000 square meters. What is this in square feet? This is what we talked about yesterday for a little bit. So if we've got 7,000 meters squared, when we want to put that into feet, if we multiply by 10.76 feet. Oh, no, it is in square feet. Oh, they already give us square feet. So 1 meter squared is 10.76 feet squared. So we actually don't have to worry about the squares here because they included it for us. Still shows that that's important to look at. So we could use a calculator, but I'm going to say it's close to 10 times 7,000, so it's going to be 75,000. C. They do make these so you don't have to use a calculator. If the calculator would have been helpful, I would have used it by now, but it hasn't been so far. Okay, so we're looking for the equation of this line. So always, you start with the y-intercept. Looks like it's positive 400,000-ish. So you cross off these negatives. And then the line goes up, not down. So it needs a positive slope. That's really like when it's multiple choice and you're trying to write equations like that. That'll pretty much get it for you. You look at the y-intercept. You look at if the slope is positive or negative. If that doesn't work, you look at the steepness. All right, what are the possible values? So you could, of course, distribute and then like refactor and stuff, but no. The best way is you square root both sides. Remember the plus or minus. So that's where you get the plus or minus 9. But that's not the solution, right? Because you still have more work to do. So at this point, really, you're pretty safe to say it's B, right? Because there's 2 solutions, but it's not plus or minus 9 because there's more work you have to do. That is what I think is the most fun about the SAT, is the different logic like that of not having to actually solve the problem. Because of course you could, right? You could subtract 1, negative 9 minus 1 is negative 10. 9 minus 1 is 8, positive 8. Divide by 2, positive 4. Divide by 2, negative 5. But as soon as you see there's 2 answers, and it's not negative 9 and 9, you know what the answer has to be. Dang, we're writing a lot of linear equations. So you just kind of estimate the line. You draw the line through the points. You say, what is the y-intercept? And now you remember we like heavily estimated, right? But it's somewhere maybe around 30-ish. Definitely not 7, right? Because 7 would be down here. So it's definitely 30-ish. And then the line goes down in this case. So it needs a negative slope. Yeah, look at how fast you can get through these. If 4 times x plus 1 equals 16, what is the value of x plus 1? So this is pretty quick if you actually solve for x, but recognize you don't need to. You divide by 4, immediately you get that x plus 1 equals 4. All right, was there no question down here? Weird. The equation that represents that, the density of copper is that. What's the density of zinc? Okay, so let's actually read the question then. So the equation that represents the density of a copper zinc alloy, where C is the density of copper. Oh, got it. C is the density of copper, N is the density of zinc, and then 8.87 is the density of the alloy. Got it. So we're looking at percentages, right? So it's 95% copper and a 5% zinc. That's the whole idea. So the density of copper is 8.96. So we have 0.95 times 8.96 plus 0.05 N equals 8.87. And so we're just calculating, we're solving for N. And yeah, I can't estimate this without a calculator. So we'll just do it in the calculator, that's fine. So we could we could actually have the calculator solve for us, but that would take way too long. We don't need to do that. Notice how whatever this number is, we're going to subtract that to the other side. So that's 8.87 minus 0.95 times 8.96. Order of operations should make that fine for us. So we get positive 0.359. I suppose that makes sense. And then, oh yeah, it would have to be, because then we're going to take that and we're going to divide it by 0.05. And that's going to be our answer. That's going to be what N is equal to. Yeah, so that's just like making the correct substitution and then solving for N. That would be in the plug in and solve section. All right. The score of 30 points is removed from the list. The low outlier is removed from the list. How will this affect the mean and the median? So the whole idea about the mean and the median is that if you remove an outlier, that does not change the median very much, but it will change the mean a lot. So the mean will definitely increase. Toss those off. Will the median remain the same, or will the median decrease? The median's never going to decrease. They're always going to go in the same order. I I don't think you could even make up a weird situation where removing a data point will increase the mean but decrease the median. Pretty sure that's not possible. So remain the same, that makes sense. And why will it remain the same? Well, right now it's odd. So what's the middle number? It does go from greatest to least, so that's the middle number. So look at how when we remove the 30, now we don't have a middle number. Now we have to average those two for the median, but the average of that is still 71. So the median stays the same. And that is literally the entire point of the median, is that it doesn't change based on outliers. That's why often the median is better to look at. All right, one of the two equations in a system is given. The equation has infinite solutions. So that's like just the very first problem we did today. If it's got infinite solutions, that means they're the same equation. We're really just looking for the same equation. So it looks like they're multiplying everything by 2. So you get 4x minus 6y equals 10. And that would be the same equation. If we were looking at infinite solutions, or no solution, you'd be looking at something like this. Because look how there, the right side of the equation is the same. You're saying that 2x minus 3y is equal to 5, but at the same time, you're saying that 2x minus 3y is equal to 10. It can't be equal to two things at the same time. So that's just got to be that. That would be no solution, because that wouldn't be possible. All right, 16. Points A, B, and C lie in the circle. What is the measure of arc AC? So when they talk about measures of arcs, I hate how there's a length of an arc and there's a measure of an arc. So the measure of an arc is talking about the angle. And more specifically, it's talking about if you made that arc with a central angle, an angle in the middle, the measure of the arc is the measure of that angle. So we have to draw that, and we have to say what is the measure of that angle. And that's really just a geometry property. So we have that this is 55. So what is that? I want to say external angle, but I don't think that's the right word. Might actually just be an internal angle. So if that angle, it's like if the angle on the edge of the circle is 55, the angle in the middle of the circle is double that. That's the property. So it's 110. So sometimes you might have to go the other way. And so to remember which way you go, you just look at which one is bigger. You see how the central angle was bigger than the outside angle? So that just tells you that you got to double to get there. And if they gave you the central angle, you would have to half it to get to the middle. Okay. 17. Which ordered pair is a solution to the system of inequalities? So we could graph these and shade the area. If they gave us the graph, that'd be the way to do it. But the way to do it with the equation is just plugging stuff in. We know when we plug in the point, it has to work for both equations. And that doesn't take as long as you might think. So when you plug in 0 and you plug in 2, is 2 less than 4? Yes. When we plug it into the bottom equation, is 2 greater than 4? No. So it's not B. And you just do that for all of them. So you plug in 1 to the top one, 0 less than a positive number. Yes. Plug into the bottom one. 0 greater than negative 2 plus 4. No. Plug in 1 and 5. 1 half plus 4 is not greater than 5. So it can't be that one. So then it has to be D. Check it real quick. You plug in 2. You get that 4 is less than 5. Yes. Plug it into the bottom one. You get 4 is greater than 0. Yep. Yep. Next. So what does this negative 2 do? A negative 2, it's on the outside, so it's moving the entire thing down 1. So I would look at how right now this asymptote is at 1. We're going to move it down 2 because it's minus 2. So move it down 2 should be at negative 1. Looks like just that one. Okay. The GDP of Malta was approximately 250 in 1970. From 1970 to 1980, the model indicates the GDP increased by 15% per year compared to the previous year. Which function represents that? Okay, so starting in 1970, so we've got our original amount, or the original amount is always the number multiplied on the outside. And that's actually the only one that works. The next thing I was going to say is here we got the rate. It's a 15% increase. When you think about percent change, you should always think about 1 either plus or minus, whatever that rate is. And then you raise it to the t. So there we go. It's d. Beautiful. All right. The box plots shown summarize the number of tanker and dry bulk merchant fleets for 1800s. Which of the following measures must be greater? Which of the following measures must be greater for the number of tanker fleets than the number of dry bulk fleets? It's weird for me that like it must be, because they're showing both of these on the graph. It's not like we're talking about the mean. Like we could discuss like where the mean could possibly be, but the median is right here. When you have a box plot, the middle line on the box plot is the median. So we see that the tanker median is higher. What are they asking about? Which must be greater for the tanker than the dry bulk? Yeah, so the median is definitely higher. We can see that right there. So it's not that. It's not that. But is the range higher? So what is the range? The range is like the minimum to the total maximum. So it looks like for there it's about 0 to 300-ish. So maybe it's 300. Oh god, do I have to actually like calculate these? Hold on. So what is this? This is 20. This is 400. So the range here, the range on top is 380. Oh, and that's definitely bigger than the bottom one, right? Because the bottom one is like 0 to 300 something. Okay, so yeah, the range is also bigger. So 1 and 2. Yeah, the range is just biggest to smallest. That's the way you should be thinking about that. All right, here, how many solutions does the equation have? So this one's kind of cool. You could, of course, distribute, combine like terms and factor. That would be the slow way to do it. But look at how they both have x minus 12 in them. So this is kind of weird to some people, but you can absolutely factor out that x minus 12 to the front. And if we do that, what are we left with? An x right here and a minus 12 right there. So that's what's going on here is when we factor it, like this is definitely a quadratic, so you're quick to say like 2 solutions, but it ends up that both solutions are the same. So double root, we have 1 solution. Okay. The average price per pound of oranges at a certain grocery store started at $1.15 and increased at a constant rate each month for several months until the average price per pound was $1.41. The equation represents this situation where x is the number of months after the average price per pound was $1.15. Yes. What is the best interpretation of 0.065? So 0.065, you look at the equation, this is like a y equals mx plus b thing, right? So that's the rate. So it's not the average price per pound. It's not a percentage increase. We're not doing this as an exponential. It's a linear. So it's the rate of change. You'll like to see that. I'll almost circle it already. And it's definitely not a total increase. They always throw this in here. You're not going to get a total increase from an equation. Generally. Definitely not a linear equation. You're going to get a rate of change. Okay. And this rectangle, AB is 6. CD is also 6 because it's a rectangle, obviously. And AC is 10. Beautiful. What is the length of CE? All right, so first off, I would say, I don't know if we're going to need this, but you look at your right triangle here. We have 6 and 10. So you know your triple, 3, 4, 5. That's going to be an 8. So we know the long side of the rectangle is 8. And what is it that we want? We want this length right here. So what could we do about that? It's not obvious. Oh, that's what we do. We can solve for that. Oh, no, we don't know that this is 10. So this is 10 minus x here. I mean, we can definitely do that. That seems kind of roundabout. But we could definitely say, we know that x squared plus y squared is going to have to be 6 squared. And then we also know that 10 minus x squared plus y squared has to be 8 squared. Because you see we have those two right triangles at the top. That seems kind of sucky. I guess it's not that bad. Yeah, so here's what we're going to do here. We're going to be a little fancy with it. So we're going to distribute this. So 100 minus 20x. And then look at this. Plus x squared plus y squared equals 64. But what is x squared plus y squared? We know exactly what that is. X squared plus y squared is 36. So what we really have then here, we'll go over, is 100 minus 20x plus 36 equals 64. And that right there is going to allow us to solve for x. So math is a little difficult. We'll subtract 36. That should be 28. And then we're going to subtract 100. So that's negative 72. Negative 20x equals negative 72. So then the answer is negative 72 over negative 20, which isn't that bad. Negatives cancel. 72 over 2 is 36. 36 over 10, 3.6. That is an answer. That's scary. Feels like there should be... Is that a 345 as well? You don't know that, do you? Maybe. I don't know. It's definitely 3.6 though. I think that's a fine system of equations to have to solve. Oh, we should have wrote down there, because this isn't even a problem. Okay. Number 24. So we got that table that we need to be referring to. So it's store X. See where that is. A customer buys 4 tires and receives the discount, but does not have the tires installed. What is the total cost to the customer? Okay, so we go store X is looking at $90 per tire. Also, each tire is 15% off the list price. So we're just doing 90. He bought 4 of them, so we multiply it by 4. And then you do 15% off. So he pays 85% of that. And remember, order doesn't matter. It's all multiplication, so you can have fun with it. And then, yeah, we'll just put that into the calculator. I feel like it's going to be the 300, but we'll just pop that into the calculator. 90 times 4 times 0.85 is 306. Yeah. It's hard to estimate because those were too close. Yeah, so we bought 4 tires and he got 15% off. Easy peasy. Store W's total expense for selling and installing 4 tires is $100. Which function represents the profit from selling and installing $4? So we got to go to store W, and we got to say how much are they doing? Ooh, they're selling $8 per tire. Okay, that makes sense when I look at the equations. So what is profit? Profit is money received minus expenses. So how much money are they receiving? Well, they're selling 4 tires. Ooh, but they buy 3 tires at the list price and get the 4th one for free. So they're actually only buying 3 tires. So they're buying 3 tires. They're paying $8 per tire. Ooh, but they also pay $50 to install them, right? So it's $8 per tire. It's buy 3, get 1 free. And they pay $50 for installation. So that's how much the person is giving the store. And then the store is paying a total of $100. That's how much it costs for them to buy and install them. And so there you go. 3A, 50 minus 100, 3A minus 50. B. Yeah, that should do it. All right. The height of a certain tree is... Height of a certain tree in 2016 was 1.35 times the height of the tree in 2011. What was the percent did the height of the tree increase from 2016 to 2016? So, percents, you just got to set up the equation. You got to not try to jump right to it. It's probably not 35%. So, the height of tree 2016 was 1.35 times the height of the tree in 2011. So, we're going to go price in 2016 is 1.35 times the height in 2011. By what percent did the height of the tree increase from 2011 to 2016? Okay, so it is just simply 35% then. Because remember, that's the 1 plus the rate, what we have right here. So the rate is 0.35, which is 35%. The 1 is the 100% that it started with. All right, here. So I think this is the thing we talked about yesterday. The more bigger the sample size, the less your margin of error. A study conducted by a mobile phone company found the average battery life of a random sample of its phones is 4.6 hours, with an associated margin of error of 0.5 hours. Study was then repeated with a much larger sample size. Yes. With the mean and the margin of error of the new sample size be calculated the same way. So the mean should be the same, theoretically. It'll be a little bit different, maybe. But the mean should roughly be the same. The margin of error should be a lot less, since we have a bigger sample size. So the margin from the error of the study is smaller than the margin of the error from the original study. Absolutely. B. Okay. A study conducted, an exponential equation and a linear equation are given. Each equation estimates the luminosity in units of billions of solar luminosity for a type 1a supernova. Much greater. The luminosity in billions of solar luminosities estimated by the linear equation 3 days after its peak luminosity is how much greater than the luminosity estimated by the exponential equation. Okay, maybe I need to read this better. Each equation estimates the luminosity in billions of solar time d days after its peak. So estimated by the linear equation 3 days after its peak. Okay, so this is just a calculator thing as well. I wish it worked better in SlideOver when I'm using my iPad like this. This is just isn't how the iPad's meant to be used. So 9.75 minus 0.83 times 3 is the luminosity from the linear equation. The luminosity from the exponential equation would be that, and they want us to find the difference. So they want us to just do 7.26 minus that answer. Okay. It's fine. 0.21. Guess we probably could have gotten that without even a calculator, right? Just by estimating. So they should be pretty close. Okay, this is a cool question. I like this question. So this question, a bag contains X apples, Y oranges, Z pears. If one of these fruits is selected at random, what is the probability of selecting a fruit that is not an orange? So what I would do right off the bat is I would say how many fruits are not oranges, X plus Z, out of all of the fruits, X plus Y plus Z. And that's a correct answer. You just see that that's not one of the options. Because they're just kind of think about it another way. What they're calculating is they're calculating the probability of getting an orange. So they're saying there's Y oranges out of the total number of things. But we want to not do that, right? So we're going to take the 100% of possibilities, 1, and subtract all of the possibilities where we get the orange. So D. Another way to see what they did is that if we took what we originally did and said, well, what if we said that on top we have X plus Y plus Z minus Y? That's the same thing, right? Because the Y cancels itself out. But then if we have it as X plus Y plus Z minus Y, look at how now if we hard it, we have X plus Y plus Z over X plus Y plus Z, which is 1, minus Y over X plus Y plus Z. So that's the other thing about multiple choice problems, is that maybe you get one form of the answer, but that's not an option. So then you have to move stuff around. All right, I think this is our last multiple choice question, and it is: the histogram shows two data sets. Which of the following best compares the range and the standard deviation? Okay, standard deviation. Well, range and standard deviation are similar, right? Usually a bigger range means bigger standard deviation. Not always. But the range of data set P is definitely bigger, right? It's going from 0 to 34. Or maybe 4 to 30. But this is going 5 to 29 at the maximum. So the maximum range there is 24. Minimum range here is 26. So P definitely has a bigger range. So cross those off. I think it's got a greater standard deviation too. Because look at how all of these people, they're kind of humped in the middle. They're all actually right around from like the 10 to 19 age group. Whereas dataset P is all over the place. So dataset P has a bigger deviation. Those points deviate more from each other. And that's all it is. All right, what is the median? So we got to look here. If there's 25 data values, what's the middle point is the way to do it. So the middle point should be the 15th, right? Quick way to do it is you subtract 1 and you divide by 2. Actually, no, that's not right. I totally did those numbers wrong. It should be the 13th, right? You add 1 and you divide by 2. So if you have the 13th, that's the 1 in the middle. That means you have 12 on each side, and you see how together, that's a 25. So we're looking for the 13th data point. So we just got to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's the 9th. You should be able to do it the same way from the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yep. The median is 9. Next. The given equation rounds the volume X of a 10% solution mixed with the Y of a 20% solution to get an 18% solution. Yeah, we could have just written that equation ourselves. What volume in gallons of the 20% will be needed if 50 gallons of the 10% is used? Okay, so they're saying X equals 0.5, solve for Y. So if X equals 50. So 0.1 times 50 is 5, plus 0.2 times Y equals, and we'll distribute. So what's 0.8 times 50? Is 90. Or 9. Plus 0.18 Y. So now we subtract 0.02 Y is 4. We multiply by 50 to get that Y is 200. And then we got to say, does that make sense? And I think it definitely does, right? Because this is 10% and this is 20%, and we're combining to get an 18%. So we definitely need a lot more 20% than 10%. So that makes sense. 200. All right, so this scatter plot for how many of the data points does the line of best fit predict a greater Y value than the actual Y value? So we had one just like this before. These are our actual Y values. The line is the predicted Y values. So it looks like for 3 of them, the line is greater than the point. Oh, if A minus X is a factor where A is a positive constant, what is the value of A? Okay, so we need to factor this. So start off, what can we pull out of everything? Definitely an X, right? Definitely a 3. I think that might be it. So what do we get after that then? So we pulled out a 3. That's not subtraction. That's division. So we're left with a 2. X squared. We're left with 9x. 54 over 3 is like 60 over 3 minus 2. So 18. We took away the x. So we're left with this. And they want us to keep factoring this. So I use the Richmond method to factor stuff like this, which makes people angry sometimes. But I rewrite this equation as this. I factor that, and I say, how do you factor that? That's x plus 12 times x minus 3. And then now I go back and I divide these by 2. So then I get x plus 6 times 2x minus 3. And you could check for yourself real quick. You get 12 minus 3x. It does indeed work. So this is it fully factored. So what are we looking for here? Oh, yeah, one of the factors is ax minus 3. So we're looking for that one. So 2. A is 2. Very good. Very good. Set K consists of all positive integers that are less than or equal to 150. How many numbers is that? 150. Where none of the integers are repeated. If a number is selected at random from the set of K, what is the probability of selecting a number that is even and less than or equal to 130? Everybody always forgets part of that. It's even and less than or equal to 30. So how many numbers are even and less than or equal to 30? Because it's definitely out of 150. So there's 30 numbers that are less than or equal to 30. But only half of those are even, right? Half of all the numbers are even. So it's actually 15 out of 150. Or 1/10. All right. This is the important one. So the volume of sphere A is 20 cubic centimeters. Sphere B has a radius that is 2 times bigger than A. So this is what we always say. If the radius, which is a length, is 2 times bigger, the area, in this case we'd be talking about surface area, is 2 squared times bigger. The volume is 2 cubed times bigger. 2 cubed is 8, so we're talking about 20 times 8, which is 160. So other people would be trying to be like, oh my god, what's the volume of a sphere? A volume of a sphere is 4/3 pi r cubed. So 4/3 pi r cubed equals 20. And then we try to solve for r. So we'd go r equals 60 over 4 pi cube root of that. And then we'd say, oh, well, the new radius is 2 times that. So what we should really be looking at here is 4/3 pi times 2 times the cube root of 60 over 4 pi cubed. And we want to know what that is. But look how the entire idea is when we cube this, we're just going to get back to our 60 over 4 pi, like our old radius. And when we cube this, it's just going to be multiplied by 8. So, I mean, we could type this in just for funsies. So 4/3 pi times 2, raise that to the 1/3, 60 over 4 pi raised to the 1/3, because that'll do the cube root, and then all of that cubed. And that should just be a clean 160. It is. Well, look, we didn't have to go through all of that, because you know the pattern. If you multiply the length by A, you multiply the volume by A cubed. Very good to know. Okay. When Katrina walks from home to work, she burns 5.3 calories per minute. When she rides her bike from home to work, she burns 6.4 calories per minute. If Karina spends a total of 6 hours walking and bicycling from home to work in a week and burns that many calories, how many minutes does she spend biking? So this is just a classic system of equations, right? Maybe we'll solve it in the calculator even. So when Katrina walks home to work, she burns 5.3 calories per minute of walking plus 6.4 calories per minute of biking. And she burns a total of 1941 calories. And she spends 6 hours, right? So here's the whole thing. We've been doing all this in minutes, right? They even underline it for us. That was very, very nice of them. So instead of using 6 hours, we'll use 360 minutes. So the amount of time she spends walking plus the amount of time she spends biking is a total of 360 minutes. And now we just got to solve this system, right? So let's let NumWorks really shine here. So we'll go to equations, and we'll type in both of these equations. I'll probably use x and y. Actually, I don't even need to. Yeah, I'm going to use x and y. So 5.3x plus 6.4 y equals... Oh, that's right, because I forgot the quicker way to do this. Equals 1941. So what we should have done is when we added equation, we didn't need to add empty. We should have added that one. But now it's nice. We'll just do that equals 360. And so look, we literally just type in our two equations here, and then we tell NumWorks to solve it for us. And they tell us that x is 330, which was walking, and biking was 30 minutes. So how many minutes did she spend biking? 30? That's kind of surprising. Let me make sure I type these in right. 5.3x, 6.4y is 1941. Yeah, that's right. Okay, that's the last problem. A quadratic function can be used to model the height of an object above the ground in terms of seconds after the object was launched. Yeah, because gravity. According to the model, an object was launched into the air from a height of 0 feet and reached its maximum height of 784 feet 7 seconds after it was launched. Based on the model, what was the height in feet of the object 3 seconds after it was launched? Okay, so let's see. I mean, I know the physics equation, but then we have to, like, I guess, throw gravity on there. Well, no. What should we really do? What should we really do here? So I definitely like maximum height. So what we should think about is, like, that's what it is looking like, right? And actually, they even tell us that it starts from 0. So we know one of our x-intercepts is 0. So if we wanted to start, we could say that we have x times x minus something here. Ooh, and I guess times some number on the outside. Okay. But here's what we actually can definitely say. Because if it hits right here at 7 seconds, it's going to take an equal amount of time to get back to the ground, right? So that actually tells us right there that this has to be 14. It's going to hit the ground again at 14 seconds. If it hits its maximum height at 7 seconds, starting from the ground, it's going to hit the ground again at 14 seconds. So then the last thing we just have to do is we have to figure out what this b would be. And we'll do that just to make sure it goes high enough. So we'll say that at 7 seconds, so some number times at x equals 7, 7 times 7 minus 14 has to get us the 784. So this is just back to the calculator, right? I would say 7 minus 14 is 7. 7 times 7 is 49. So we got 784 divided by 49, which is a clean 16. Negative 16, of course, because that's not negative and we're dividing it by a negative. So b is negative 16. So that's the equation. I don't even know what we're looking for yet. We might be working way too hard. So we have our equation now. This b is negative 16. So x times x minus 14 is what our y value is. What's up, Hugwin? You're right here for the last question. So then what do we want to know based on the model? What is the height 3 seconds after it's launched? Now that we have our equation, we've simply got to plug in 3. I will just do that in the calculator. 16 times 3 times negative 11, but the negatives cancel out. You end up with 528. Beautiful. And that should be it. We'll check our answers real quick to make sure we're right, but that should be it. So we got them all right, and that's really all we could hope for. So you got your April SAT, you got your April school day test coming up soon. So if you can read, I recommend you do the reading section as well. But if you're like me and you can't, just try to do really well in the math section. Math's all that really matters anyway.